Good morning. In today's session, I am going to explain you the previous questions given from Newton's laws of motion. From 2019 to 25, in these years, more than 100 questions are given. That means in every session, in every physics question paper, there is at least one question based on Newton's laws of motion. It is such an interesting and easy topic, and nobody should miss a question. So, you do not miss a question if you sincerely follow this PYQ explanation. I am so confident about you. Be ready. Okay? Now, let us start the PYQs from Newton's laws of motion. See here. 19 to 25 JEE main physics PYQs, Newton's laws of motion and conservation of momentum. Read this first question. An object with mass 500 grams. Mass of the object is given as 500 grams. It is converted into kg. It becomes 0.5 kg. Moves along x-axis with a speed v is equal to 4 root x. The force acting on the object. We know force is equal to m into a. We can find acceleration from this in two methods. I am telling you the shortest method. See, if you remember equations of motion, v square minus u square is equal to 2as when acceleration is uniform. So, on squaring this equation, v square is equal to 16 into x. If you compare this equation with this equation, initial velocity will be 0. In place of 2a, here it is given as 16, from which acceleration is 8 meter per second square. So, acceleration is found, mass is found. From this relation, force applied is equal to m into e, that is 4 Newton. So, this is the correct option for that problem. Okay? Now, let us move on to the next problem. Body of mass 1000 kg. Mass of the body is given as 1000 kg. Moving horizontally with a velocity 6 meter per second. Okay, let us consider this as m1. Its velocity is given as u1. A 200 kg extra mass is added. 200 kg extra mass is added, then the final velocity will be. See here, without applying any external force, just mass is added to the system. So, law of conservation of momentum says that in absence of external force, the total momentum of the system is conserved. So, what is the initial momentum of the system? m1 u1. Finally, to this mass another mass is added. So, final mass of the system m1 plus m2 into v. You are supposed to find velocity, final velocity. So, from this v is equal to m1 u1. V is from this formula m1 u1 by m1 plus m2. You just substitute these values here. m1 is 1000, u1 is 6. m1 plus m2 is 1000 plus 200, 1200. This is 5. So, velocity, their common velocity or the final velocity of the system is equal to 5 meter per second. So, the correct answer for this is this option, option C. Now, move on to the next problem. A machine gun of mass 10 kg fires 20-gram bullets at the rate of 180 bullets per minute. The time is 1 minute, that is 60 seconds, with a speed of 100 meter per second. Velocity of each bullet is given as 100 meter per second. A recoil velocity of the gun. See here, mass of each bullet is given as 20 grams, that is 20 into 10 to the power of minus 3 kg. Velocity of each bullet is 100 meter per second. What is the recoil velocity of the gun? That means when bullets are fired, what is the velocity of the gun in the backward direction? From the law of conservation of momentum, the total momentum is conserved in absence of external force. So, the total momentum before firing is 0, that is m1v1 plus m2v2, where m1v1 plus m2v2 is the total momentum of the system after firing. So, here see 0 is equal to the total momentum of all the bullets together is m into n. Number of bullets fired per second is 3. So, here it is 180 by 60, that is equal to 3 bullets per second are fired. So, mass of all the bullets is 20 into 10 to the power of minus 3 into 3, and velocity of each bullet is 100 plus mass of the gun is given as 10 kg. This is mass of the gun is given as 10 kg, its velocity we need to find. So, from this 10 V2 is equal to 1, 2, 3, 10 power minus 3 gets cancelled. It is, if you bring this to this side, it is minus 6. So, V2 is equal to minus 6 by 10, or V2 is equal to minus 6 meter per second. That negative sign indicates as the bullets are moving in this direction, the gun moves in the backward direction. That negative sign indicates direction of velocity of the gun is opposite to that of the bullets. So, recoil velocity, in the question he asked what is the velocity of the gun in the backward direction. So, we need not put the negative sign once again, because he asked us to find the velocity of the gun in the backward direction. So, answer is 0.6 meter per second. If that word recoil is not mentioned, if he simply asks what is the velocity of the gun, the answer will be minus 6 meter per second. What is the recoil velocity of the gun? Then that minus is included in the question. So, your answer is 6 meter per second. Now, look here. A balloon has a mass of 10 grams in air. Air escapes from the balloon at uniform rate with a velocity 4.5 centimeter per second, and the balloon completely shrinks in 5 seconds. The average force acting on the balloon is how much? Force is equal to m into acceleration, that is mv by t, or m by t into v. If mass is changing with respect to time, keeping velocity as constant, it will be m by t into v. If mass is constant, it will be m into v by t. So, here it is mass rate is 10 grams. Initial mass is 10 grams. It is completely collapsed in 5 seconds t, and velocity of the balloon is 4.5. If you notice this, everything is given in CGS system. Mass is given as 10 grams, velocity is given in centimeter per second. So, everything is in CGS system. The force unit in CGS system is dyne. So, it is 2 into 4.5. The answer is 9 dyne. So, you are actually asked to express the answer in dyne. So, it is 9. Suppose if the data is given and if you are asked to find the force in Newton, you have to know to convert dyne to Newton. So, it will be 9 into 10 to the power of minus 5 Newton. 10 to the power of 5 dyne is 1 Newton, or 1 dyne is equal to 10 to the power of minus 5 Newton. Okay? Move on to the next problem. Look here. A block of metal weighing 2 kg. This is a metal block weighing 2 kg is resting on a frictionless plane. As shown in the figure, it is struck by a water jet striking at 1 kg per second. M by T is equal to mass of water striking the block per second is 1 kg per second, and its speed is given as 10 meter per second. 10 meter per second. The initial acceleration of the block. Look here, mass of the block is 2 kg here. So, water strikes the block with a velocity v at that rate. So, here force exerted by the water jet on the block is m by t into v, that is 1 into 10. So, this is 10 Newton. So, force on the block is 10 Newton, mass is 2 kg. So, what is the acceleration of the block? Initial acceleration of the block. Look here, 10 meter per second is the velocity. So, mass of the block. What is the acceleration? Acceleration is force by mass. It is 10 by 2. It is 5 meter per second square. So, acceleration is 5 meter per second square. Now, look into this next problem. An object is thrown vertically up. At its maximum height, which of the following becomes equal to 0? When a body is at a height h, see here, its velocity is equal to 0, hence momentum, as momentum is mv, momentum will be equal to 0. So, at the highest point, momentum becomes 0. Potential energy is not equal to 0 because it is at a height from the ground level. So, potential energy is not 0, it has finite value mgh. Acceleration is g in the downward direction. So, acceleration is not 0. Force acting on it is the gravitational force mg acting in the downward direction. So, everything else except the momentum is 0 at the highest point of a vertically projected body, because in case of a vertically projected body, velocity at the highest point is 0. Okay? Now, look here, it is an interesting question. 2 billiard balls of equal mass 30 grams strike a rigid wall with the same speed of 108 kmph as shown, but at different angles. If the balls get reflected with the same speed, then the ratio of magnitude of impulse imparted to the ball A and B. This is ball A and this is ball B. Ratio of impulses. Here, impulse is nothing but change in momentum. Impulse is nothing but change in momentum. So, here change in momentum is m into u minus of minus plus u in the first case. Impulse in the first case is m u because change in velocity is 2u here, u minus of minus. Similarly, in this case, in this direction it is u cos 45, and for this component is u sin 45. For this component is u cos 45 and this component is u sin 45. So, there is no change along the wall, there is change in velocity normal to the wall. So, as far as the wall is concerned, in the second case, it strikes the wall with a velocity u cos 45, it gets reflected with a velocity u cos 45. So, in the second case, change in momentum is m u cos 45 minus of minus u cos 45. So, if you take that mu here, it is 2 mu, it is 2 mu cos 45 in case of ball B. Now, what is asked? The impulse imparted to the ball A and ball B. So, I1 by I2 is equal to 2 mu by 2 mu cos 45. So, 2 mu gets cancelled, 1 by cos 45 is 1 by root 2. So, the answer is root 2 is to 1. So, actually in this question we can straight away eliminate these two options, because in this case it is head on collision, impulse will be more in the first case. So, answer, this is eliminated, but on solving you got the first option as the correct option. Now, look into the next problem. A particle of mass m is moving in a straight line with momentum p. Momentum of the particle is given as p here. Starting from time t is equal to 0. Initial velocity is 0. The force F is a variable function of time, F is equal to kT. Acts in the same direction on the moving particle during the time interval t. So, force acts for time t, so that the momentum changes from p to 3p. What here k is constant, what is the value of t? So, we know impulse is change in momentum, that is p2 minus p1, and another thing is impulse is, if force is a variable function of time, F into dt. So, here F into dt, that is F is given as kT here, kT dt. It is acting during the time t is equal to 0 to t, 0 to t is equal to k, integral of t is t square by 2, 0 to t. So, impulse is equal to k t square by 2. This is equation 1. From this, impulse is equal to final momentum minus initial momentum. Impulse changes from p to 3p. Final minus initial, that is equal to 2p. This implies 2p is equal to kt square by 2. What is asked in this question? You are supposed to find the value of t. From this, t square is equal to 2 into 2 into p by k, which implies, this implies t is equal to, if you take square root, it is 2 square root of p by k. 2 root p by k is the correct answer for that problem. Okay? Now, let us move on to the next problem. Look here. read the problem carefully. A body of mass 2 kg. Let us note the data here. Mass is given as 2 kg. Is moving with a velocity 3I plus 4j meter per second. Velocity vector is given as 3I plus 4j meter per second. Enters into a constant force field of 6 Newton directed along positive z axis. So, force is equal to 6 k bar positive z axis. That means unit vector along z axis is k bar. So, F is equal to 6 k bar. Body remains in the field for a period of 5/3 seconds. Force acting on the body is about 5/3 seconds. Then velocity of the body when it emerges. So, here acceleration is F by m 6/2, this is 3 meter 3 k bar meter per second square. So, as acceleration is along z axis, there will not be any change in x and y component of velocity. So, final velocity is u plus at. As initial velocity along z axis is 0, velocity along z axis at t is equal to 5/3 is acceleration along z axis is 3, time is 5/3 seconds. So, it is 5 k bar. So, the net velocity at the end of 3 seconds is v bar is equal to 3I plus 4j plus 5k. That is the final velocity of the body when it is moving in the constant force field. So, here the most important thing is the force is positive along positive z axis. So, force is acting along z axis only. So, its velocity along y axis and x axis do not change because component of a force which is acting along z axis along xy axis will be 0. If force is acting along z axis, its component along x axis is 0, along y axis is 0. Hence, along x axis and y axis there is no change in velocity. Along z axis we could find out the velocity, along z axis we could find out the velocity after 5/3 seconds. So, that is the answer. Okay. Now, look here, a balloon and its contents have mass m. It is moving up with an acceleration a. The mass that must be released from the content so that the balloon starts moving up with an acceleration 3a. So, here the key words are initial mass of the balloon is m, it is moving up with an acceleration a. Then m into g plus a, that is in the second case some mass is released from the balloon, then it started moving up with acceleration 3a. That is the equation. When it is moving with upward acceleration a, m into g plus a is its apparent weight. When some of its mass is removed, its apparent weight is m minus m into g plus 3a. Right? So, here you are supposed to find this m. So, m into g plus a is equal to m into g plus 3a minus m into g plus 3a. Okay. So, here very obviously you can guess the answer, isn't it? Something divided by g plus 3a you will be getting. So, g plus 3a option is only this. So, you can, if you are smart enough, you can directly choose the option. Anyway, let us solve that. Now, let us take this to this side. M into G plus 3A is equal to M into G plus 3A minus G minus A. We are bringing this to the other side. G and G gets cancelled. M into G plus 3A is equal to M into 3A minus A is 2A. So, that implies you are supposed to find the mass which is removed, M, is equal to 2 M A divided by G plus 3A. 2 M A divided by 3A plus G, that is the mass removed from the balloon. Is it all right? Okay, that's quite interesting problem. Now, let us move on to this question. A wooden block initially at rest. So, you have to concentrate on the keywords. Initially at rest, it is pushed by a force which increases linearly with time. Force increases linearly with time. Which of the following curve best describes the acceleration? So, F is equal to M into A. So, acceleration is proportional to force. As force is proportional to time, acceleration is proportional to time. So, it is this graph is correct. Linear relation between acceleration and time. So, as acceleration is proportional to t, acceleration time graph is a straight line passing through the origin. Okay? Now, move on to the next. Look here. Position vector of a particle related to time is given by this expression. Direction of force experienced by the particle. Positive x-axis like that. So, F is equal to M A. F is a vector because acceleration is a vector. So, direction of force is in the direction of acceleration. So, let us try to find out the direction of acceleration from the position vector given. So, its position vector is given as 10t I bar plus 15t square j bar plus 7k bar. If you differentiate this with respect to time, you get velocity. If you differentiate displacement vector or position vector with respect to the time, you will be getting velocity. So, this is 10, derivative of time is 1 plus I bar plus 15, t square derivative is 2t, j bar plus constant derivative is 0. So, this is velocity vector is 10 I bar plus 30 t j bar. You are asked to find the force direction. So, you have to find out the acceleration. So, how do you get acceleration from velocity? By differentiating velocity with respect to time, we get acceleration. So, let us differentiate this with respect to time. Derivative of constant is 0, this is 30, derivative of t is 1, 30 j bar. So, acceleration is along j bar, that is positive y axis. Hence, force is along positive y axis. That is the correct answer for that problem. Now, let us move on to the next problem. 10 balls each of mass m moving with a speed v simultaneously strike a wall normally and reflected back with the same speed. Total force exerted. See here, they strike the wall with a velocity and they are reflected with the same velocity with the same speed in the opposite direction. So, here force exerted by the balls on the wall is m n into change in velocity by time. So, m number of balls is 10, change in velocity is 2v by t. So, it is 20 mv by t is the answer. Oh, not 10 balls, n is 100 balls, it becomes 200 mv by t, this is the answer. So, directly you can say, isn't it? If the ball strikes the wall and bounces back with the same speed, change in velocity is 2v, change in momentum is 2mv, 2mv by t in case of one ball. In case of n balls, it is 2mnv by t. So, directly 2m, n is given as 100 into v by t, that is the force, or 200 mv by t is the answer, right. Let us move on to the next problem. Figure represents the momentum time curve for a particle moving along an axis under the influence of force. So, momentum time graph. Identify the regions on the graph where the magnitude of force is maximum and then minimum respectively. So, you have to identify the regions in which force is maximum and then minimum respectively from PT graph. So, the relation between force and momentum is force is equal to rate of change of momentum dP by dt. So, very obviously from PT graph, the slope of the graph gives dP by dt. Hence, slope gives the applied force. Slope of PT graph gives applied force. For a straight line, slope is constant. So, here this is a straight line, this is a straight line, this is a straight line. Very obviously, for this time, the slope of this graph is maximum by looking at the figure. Okay? So, slope is maximum in this region, and in this region slope is just more than 0. So, this is the least minimum slope, maximum slope. You have to find maximum force, minimum force regions. So, this is the maximum force region and this is the minimum force region. So, answer is C and B, maximum and minimum. So, maximum slope here and minimum slope is here. So, maximum, minimum C and B, that is it. So, you have to know only this relation. F is dP by dt. From this expression, the slope of momentum time graph represents force. I read the problem. In two different experiments, an object of mass 5 kg moving with a speed. Mass of the object is given as 5 kg and its velocity is given as 25 meter per second, hits two different walls and comes to rest within 3 seconds, within 5 seconds respectively. So, initial velocity is this and comes to stop, final velocity is 0. So, choose the correct option. Just impulse and average force. So, they are talking about impulse and average force in all the statements or all the options. See here, impulse is change in momentum. Impulse is equal to change in momentum. Very obviously, this is I is equal to m into u minus 0. In both cases, impulse is same. Okay, and coming to the force, impulse is force into time of action of force. As impulse is constant here, T is inverse, F is inversely proportional to T. Impulsive force F is inversely proportional to T. So here T1 is 3 seconds, T2 is 5 seconds. T1 is less than T2. As force is inversely proportional, F1 is greater than F2. So here the answer is going to be impulse is same in both cases, force is different in the two cases. So impulse and average force will be same. Wrong. Impulse will be same for both, but average force will be different. Average force is same, impulse is different, both are different. So the correct option is impulse is same for both, but average force will be different. In particular, if they ask you which force is more, very obviously force in the first case is more than that of second case. Or if you are asked to find the ratio of forces, impulsive forces, it is inversely proportional to time. So F1 by F2 is 5 by 3, and impulse, as impulse is same, I1 by I2 is constant, that is 1. So the same question in some other exam, the ratios of impulses and forces are asked. So further, that is the answer. Okay. Now let's move on to the next problem. Look here. A body of mass m at rest explodes into 3 pieces of masses ratio 1:1:2. 2 smaller pieces fly off perpendicular to each other with velocities 30 meter per second and 40 meter per second respectively. Velocity of the third piece. Let us assume mass of the first piece is m, mass of the second piece is m. What will be the mass of the third piece? Because the ratio is 1:1:2. So the mass of the third piece is going to be 2m. Now the first piece flies off with momentum 30. So m into 30, and second piece flies off with velocity 40. So momentum of the second piece is m into 40. They fly off at right angles to each other. If this is along x-axis, this is going to be along y-axis. Now what is the velocity of the third piece? See here, from the law of conservation of momentum, a body explodes into 3 pieces. A body at rest explodes into 3 pieces. Initial momentum is 0. It is P1 bar plus P2 bar plus P3 bar, from which P3 bar is minus of P1 bar plus P2 bar. So this is a minus of, if you take that m as a common factor, 30I plus 40J. P3 is, its mass is 2m into V3 bar. So m and m gets cancelled. V3 bar is equal to minus 1 by 2, 30I plus 40J. But value is given here. So you need to find the magnitude. What is the magnitude of the vector 30I plus 40J? So if you are, that sign indicate, negative sign indicates the direction. See here only magnitude is mentioned, half. This is magnitude of this is square root of 30 square plus 40 square, that is 50. Half into 50 is the magnitude of velocity of the third piece, that is 25 meter per second. Okay, that's a common model repeated several times in several exams. Okay, so here bomb at rest or a body at rest explodes into 3 pieces. Initial momentum is 0, final momentum is for the 3 pieces P1 bar plus P2 bar plus P3 bar. So, just the concept, we use the concept of vectors here. Let us move on to the next problem. The initial mass of a rocket is 1000 kg. So, mass of the rocket is 1000 kg. Calculate the rate at which fuel is burned so that the rocket is given an acceleration 20 meter per second square. Gases come out at a speed of 500 meter per second. So, with respect to the rocket. So, what is asked? The gases come out at a speed of 500 meter per second with respect to the rocket. What is the rate at which fuel is burnt? Look here. Let us assume this as the rocket of mass capital M. Hot gases are ejected at the rate of m by t with a velocity v downwards. As a result, from Newton's third law, it exerts a force in the upward direction on the rocket. Ejection of hot gases in the downward direction exert a force on the rocket in the upward direction, and the weight of the rocket will be acting in the downward direction. That is weight mg, and ultimately the rocket is given an acceleration, so that is a. So, as far as the rocket is concerned, if you consider the free body diagram, let this be the rocket, its weight mg acts in the downward direction, force due to the ejection of hot gases acts in the upward direction. As a resultant, it has an acceleration a up. So, F minus mg is equal to ma, or F is equal to m into g plus a. That is the net force acting on the rocket to create an upward acceleration. But this is due to the ejection of hot gases m by t into v, that is equal to m into g plus a. Now, just substitute. You are supposed to find this. So, m by t is equal to mass of the rocket is given as 1000, velocity of ejection of hot gases, this v is given as 500, g is given as 10, a is 20 meter per second square plus 20. So, here this is 2 into 30, it is 60. Mass rate at which the fuel is burnt is 230s are 60 kg per second. That is the rate at which the fuel is burnt in order to give an acceleration a in the upward direction. Actually, if you are thorough with the concept, thorough with the formulae, we directly go to this formula. M by t into v is equal to m into g plus a. That's it. So, just this is what you have to do in the exam. So, you need to be thorough with the formulae. Now, let us look into 20th problem. So, read the problem carefully. A bullet of mass 5 grams is fired from a gun of mass 4 kg. So, mass of the bullet is 4 grams, gram is converted into kg, 4 into 10 power minus 3 kg. Mass of the gun is given as 4 kg straight away. Bullet moves with a muzzle speed of 50 meter per second. Velocity of the bullet is 50 meter per second. Impulse imparted to the gun and recoil velocity of the gun. So, here using law of conservation of momentum, 0 is equal to m1 v1 plus m2 v2. This is the impulse. From this, what is m2 v2 is equal to minus m1 v1. m2 v2 is nothing but the impulse imparted to the gun by the bullets. So, impulse imparted is m1 v1. So, mass of each bullet is 4 into 10 to the power of minus 3, v1 is 50, this is 200 into 10 power minus 3 or 0.2 kg meter per second. That is the impulse, right? Next, from this relation, you can find out the velocity of the gun. So, gun's mass is given as 4, v2 is equal to minus m1 v1 is 0.2. So, v2 is equal to minus 0.2 by 4, this is minus 0.05 meter per second. So, velocity of the gun is minus 0.05 seconds. Negative sign indicates as the bullet moves in the forward direction, the gun moves in the backward direction. It is asked to find the recoil velocity. So, what is the velocity in the backward direction? It is simply 0.05 meter per second. So, impulse is 0.2 and recoil velocity is 0.05. Search for the option. So, 0.2 kg meter per second is the impulse, recoil velocity of the gun is 0.05 meter per second. Okay? So, I will stop here for today. I will continue with the remaining problems in the next session. Thank you and bye-bye.